All right, today we are cracking open the hacker's playbook to take a deep dive into SQL injection. Now, you might think this is old news, but it's one of the oldest tricks in the book for a reason. It's still responsible for some of the biggest, most devastating data breaches you hear about. So, how can a few seemingly random characters bring an entire company to its knees? Well, let's get into it. So let me ask you something. Do you think you could just walk up to a secure website's login page, type in the administrator's username, and get full unrestricted access without even knowing the password? I mean, it sounds impossible, right? Well, with a little trick called SQL Injection, the answer is a pretty terrifying yes. So here's how it starts. It's almost laughably simple. The attacker goes to a totally standard login form, but instead of typing a normal username, they type something that just looks a little weird. Administrator, followed by a single quote and then 2 dashes. It really doesn't look like much, but trust me, those last 3 characters are the key that's about to unlock the entire kingdom. Okay, so what is actually happening behind the curtain? On the left, you see the code that the website was supposed to run. It's a simple command: find a user where the username matches administrator and the password is correct. Makes sense. But look at the right. That's what actually ran because of our little injection. That double dash, slash slash, in the world of SQL, that's a comment. It tells the database, hey, just ignore everything after this point. And what comes after it? The entire password check. So the database just finds the administrator user, shrugs, and lets the attacker right in. Game over. And that right there, that impossible login, is our first real taste of the deceptive power of SQL injection. See, it's not about brute forcing passwords or some complex cryptography. It's about fundamentally tricking the application, bending its own rules against it, with nothing more than a few keystrokes in a text box. But to really get our heads around why this works so well, we need to understand the language the attacker is actually speaking. They're not talking to the website, they're talking directly to the database, and that language is SQL. You can think of SQL as the special language for talking to a massive, super organized digital librarian. That's our database. When you want to find a specific book, you go ask the librarian, right? Well, when a website wants to find your user profile or show you a list of products, it uses SQL to ask the database. So when everything is working as it should, the flow is really simple. You click on a product category, say gifts. The application then writes up a proper SQL query, sends it off to the database neatly returns a list of all the gifts, and then the application shows them to you on the page. It's a clean, predictable, and most importantly, safe conversation. The problem, of course, is when an attacker finds a way to hijack that conversation. As the source material puts it so well, SQL injection is a vulnerability that allows an attacker to interfere with the queries. They're not just politely asking for information anymore. They're literally rewriting the instructions we're giving to our digital librarian. But just logging in, that's really just the beginning. That's child's play. The real prize for any attacker is the data itself. And with a slightly different technique, they can go from just tricking the website's logic to pulling out tons of sensitive information from totally different parts of the database. The primary tool for this kind of data heist is a SQL command called union. Now, its legitimate purpose is to combine the results from 2 different queries into one neat little package. But an attacker uses it to basically glue their own malicious query onto the end of the website's normal harmless one. Before the attacker can pull this off, though, they have to do a little bit of detective work. See, for Union to work, their secret query has to return the exact same number of columns as the original one. So what do? They start probing. They'll inject commands like order by 1, which works, then order by 2, which also works. But when they try order by 3, bam, they get an error. And that error is the clue. It tells them the original query only has 2 columns. The magic number is 2. And now that the attacker knows the structure, they can build their final payload. They inject a new command that basically tells the database, hey, sure, go ahead and get me that list of gifts, but also union that with all the usernames and all the passwords from the user's table. And here's the catastrophic result. The website just thinks it's showing you a list of products. But as you scroll down, mixed right in there with the product names and descriptions is a complete list of every single username and password in the entire database. It is an absolute data breach disaster, hiding in plain sight. But what happens if the website is vulnerable, but it doesn't actually show you the results on the page? What if the attacker injects their code and nothing seems to happen? This, my friends, is where things get really, really clever. This is called blind SQL injection. So in a blind SQL injection, the attacker gets zero direct feedback. They can't see the data, they can't see any errors, they're flying completely blind. So instead of one big data heist, they have to play a guessing game. It's like playing 20 questions or hot and cold with a database to slowly, painstakingly extract information one single bit at a time. So the game begins. The attacker sends a query that is secretly asking the database a true or false question, something like this. Hey database, for the administrator's account, is the very first letter of the password alphabetically after the letter M? Now the database doesn't come back and say, yes, that's true. But if the hidden question was true, the page loads just like it normally would, maybe displaying a welcome back message. In that subtle change, that's the signal. That's the yes. The attacker now knows the first letter is somewhere between N and Z. So they narrow it down. They ask another hidden question. Okay, is that first letter alphabetically greater than T? But this time, the welcome back message is gone. The page is just generic. And that's the no signal. The condition was false. So now they know the letter is between N and T. By repeating this slow, methodical process of asking true or false questions, an attacker can literally piece together the entire password, character by character, without ever seeing a single piece of data or a database error. It's insane. Okay, so these attacks are incredibly clever, and they can sound pretty scary. But here's the good news. They are also 100% preventable. Building the vault to protect against them really just comes down to one absolutely critical principle. The root cause of this whole mess is that the user's input, the stuff they type in a box, gets mixed up with the programmer's SQL commands. The defense, then, is beautifully simple. Keep them separate, always. The secure method on the right uses something called parameterized queries. You see that question mark? That's a placeholder. The application sends the command with that placeholder, and then it sends the user's input totally separately. This way, the database knows for a fact that the user's input is just data. It's never ever treated as an instruction. So this really all boils down to a few core principles for anyone building software. Number 1, treat all user input as if it's hostile. Never trust it. Number 2, always use parameterized queries. Build that firewall between your code and the data. And number 3, if for some reason you can't do that, you need to use a super strict whitelist of only the values you will permit. And that kind of brings us to a final, pretty sobering thought. The reason SQL injection is still around after all these years is because it only takes one mistake. One developer, one single vulnerable query in an entire massive company to expose everything. Your personal data probably lives in hundreds of different databases out there. So how confident are you that every single one of them is truly safe?